Hello everyone, my name is Mr. Guajardo, and today we're going to be talking about taxicab geometry and the shortest distance. So let's talk about Euclidean geometry first, between two different points. Between two endpoints, the straight line connecting those two endpoints will represent the shortest distance between them. But how do we measure this distance? The Pythagorean theorem, or the distance formula. This is very much based on the Pythagorean theorem. As we see here, the shortest distance is going to be our hypotenuse, and we have two legs. Leg 1 is going to be x2 minus x1, and leg 2 is going to be y2 minus y1. So we square both of them, add them together, get the square root, and that'll give us our shortest distance. An example of this from the previous slide is a is -1, -1, and b is 3, 2. So let us take our x leg first. So the distance from 3 to -1 is going to be 3 minus -1, or it's going to give us a positive 4. We could even count just to make sure. So 1, 2, 3, 4. Boom. Easy. And we do the same thing for the y leg. So from 2 to -1 should be 2 minus -1, or going to be 3 since those two minuses become pluses. We count 1, 2, 3. Well, my drawing's a little bit off, but it is 3 units. So now we plug those into the distance formula. So d is equal to the square root of 4 squared plus 3 squared, which is going to be 16 plus 9. And those together equal 25. So d is equal to the square root of 25, or just 5. We can't really count it here because it's going to be a little bit sloppy, but yeah. Now going to taxicab geometry. The main difference between Euclidean and taxicab geometry is in Euclidean, as mentioned before, when we have two endpoints, the shortest distance is the straight line that connects them. But in taxicab geometry, the measurement between the 2 points consists of single unit vertical and horizontal shifts until we get to that one point. So we're going to keep moving horizontal, vertical, just keep going until we hit what we want to hit. And the main note is just taxicab geometry does not go diagonal. And this also implies a non-uniqueness for paths. So we could call it like going through like a street, going in a taxi. So in Euclidean geometry, there's only one path from, and in this picture it's going to be Alice to Starbucks. Just that one line would be the path. In taxicab, there are multiple paths that we could take, like the original path. So 1, 2, 3, 4, 5, 6, 7. Or we go up 1, 2, 3, 4, 5, 6, 7. Or we go down 1, 2, 3, 4, 5, 6, 7. They all have the same distance and they're all unique paths to one another. And now how do we actually get the distance for taxicab geometry? As we did last time, or in the last slide, we could just count them. Or we could use the formula below. D is equal to y, or the absolute value of y2 minus y1, plus the absolute value of x2 minus x1. An example we could use here, just like the Alice and Starbucks, is where Alice is 1, -1, and Starbucks is at 5, 2. So let's say Alice gets into her taxi, and then we just count 1, 2, 3, 4, 5, 6, 7. So we know the taxi has to turn 7 times or goes through 7 units of road before we get to our place. The other way is by the formula. So Starbucks being our second point, Alice being our first point, d is equal to 2 minus -1, which is going to give us positive 3, plus 5 minus 1, which is going to give us 4, and 3 plus 4 is going to give us 7. We see that they both match, and yeah, that's the two different ways to get the distance, or the shortest distance. Have any questions, please leave a comment below and I'll get to it as soon as I get it. Thank you guys for watching.